channel. In this video, we'll be learning the topic indices. Indices is a very important topic in WAEC, NECO, and any other exams. They also have real-life application in compound interest and growth problem. Now, indices. Before we go into the topic, we need to understand this. If we have 5s raised to power 3, we have something like this. Here at the top is called index. We don't call it index. We can call it power. We can also call it exponent. That is this 3 here at the top here. We call it index, power, or exponent. While this s will be referred to as the base, and while this 5 will be referred to as the coefficient. Now, coefficient just simply means the number in front of an unknown, an alphabet. Now, in this case as well too, if we have something like, say we have x raised to power 2, this I could say x index 2 is correct to say that. We could also say x exponent 2, or I could say x power 2. They all mean the same thing. Now, in indices, we have some rules or law that are guiding the use of these indices. Now, in this video, I'll be making use of x as my variable. Then you could also come across any letter like y, m, n, p, r, or whatever letter to be used as a variable. But in this video, I will be making use of x. So don't get confused. All you just need to do is understand whichever letters that are being used to represent your variable. All is important is just for you to just understand, because in exam as well, two questions may not present as x, they may present as y or any other letter, but I'm going to use s in this video. So let's take law of indices. Now, under the law of indices, the first law here, though you could attach a name to it, multiplication law, addition law, division law, power law, but no one in exam is going to actually ask you what is power law, what is addition law, what is index law. All you just need to do is understand the law and apply it. So I'm not going to add a title or a name to the law. The first one here is s raised to power a times s raised to power b. Yeah, what this is saying is that it gives us s raised to power a plus b. What this is saying is that when we have the same base and the operation between them is multiplication, what you do is take one of the base and add their power, find the sum of their power. Let's take an example to exemplify that. E.g., if we have 3 raised to power 3 times 3 raised to power 2. Now here we are having the same base 3, 3. All we just need to do is take one of the base and sum the power 3 plus 2. That's going to give us 3 raised to power 5. That's the first one. Second law, you have s raised to power a divided by s raised to power b. S raised to power a divided by s raised to power b is going to give us s raised to power a minus b. Here is saying that when we have the same base and the operation between them is division, all you do is take one of the base and subtract their power. Alternatively, this as well could also be written as s raised to power a over s raised to power b. It's also the same thing as saying s raised to power a minus b. Let's take an example to show that. E.g., if we have 5 raised to power 3 divided by 5 raised to power 2, this is going to give us 5 raised to power 3 minus 2. We're having the same base and the operation between them is division. All you do is take one of the base and subtract the power 3 minus 2. Then we are going to have 5 raised to power 1. In another case, if we have 2 raised to power 3 let's say we have 2 raised to power 5 over 2 raised to power 2. In this case, it means you have the same base, and the operation between them is division, because this line is a division. It means division. It's going to be 2 raised to power 5 minus 2, and that's going to give us 2 raised to power 3. Alternatively, this 2 raised to power 5 over 2 raised to power 2 can be written as 2 raised to power 5 divided by 2 raised to power 2. Then we can now see that it goes in line with this first one here, s raised to power a divided by s raised to power b. Then that means 5 minus 2. Then we have 2 raised to power 3. The third law, if we have s raised to power a or brackets and you have power b outside, that is, the b is an exponent, this is the same thing as s raised to power a times b, or we say s raised to power a b. Now let's take an example to exemplify that. E.g., if we have a case of, say we have 2 raised to power 3 all raised to power 2. This is the same thing as saying 2 raised to power 3 times 2, and that's going to give us 2 raised to power 6. They have the same, what you call, you have 3 here inside this bracket is a power, 2 here is also a power, or they are both exponents. All you just do is multiply the exponent together and you have what? 2 raised to power 6. Another one. If we have a case like this as well too, you have s raised to power y, close bracket, all raised to power, say we have a. Now you check here you're having x and y inside this bracket. This power outside here, or this exponent, or this index here, is for the two letters we have here, that is x and y. Then that means this means s raised to power a, y raised to power a. That is, this power is for the two we have here. E.g., let's take an example to exemplify that. If we have, say we have 2s raised to power 2, close bracket, raised to power 3. This is the same thing as 2 raised to power 3 s raised to power 2 times 3. Then this in turn will give us 2 raised to power 3 s raised to power 6. That's the fifth one. We have s raised to power minus a. In this case here, you're having a negative power. So this means this minus here will stand for 1 over x raised to power a. E.g., if you have a case of, you have 2 raised to power minus 3. This minus here will stand for 1 over, and you have 2 raised to power 3. In a case also, we have 3 raised to power minus 5. Here is going to stand for 1 over 3 raised to power 5. Now, let's take the sixth rule. In a case where you're having s raised to power 1 over a, here you see that in this case here, our power here is a fraction. Then this means we are going to have a root of x. That is, whenever you have the variable here x raised to the power of fraction, is going to just be the a root of that case. Now, to get it clearer, see in a case where we have s raised to power 1 over 2, that means what we are going to have is square root of x. Also, if we have, let's take another example, if we have 4 raised to power 1 over 2, what this means is square root of 4, and that's going to give us 2. Also, if we have 27 raised to power 1 over 3, now meaning that we are going to have the cube root of 27, and that's going to give us 3. Let's continue. Let's take the seventh law. If we have s raised to power b over a. Now, if you check in this case here now, we're also having a fraction as the power. Likewise, in this last one here to also have a fraction. But here in the fraction, you're having a numerator of 1. But in this case, you're not having a numerator of 1. How do we deal with this case? If you have this kind of case, it's going to be a root of x all raised to power b, or we are going to have a root of s raised to power b. So this is this case. Let's take an example to simplify that. Before I proceed, let me explain again. Here you have s raised to power b over a. In this case, you also have a fraction as the power, but the fraction here, the numerator here is not 1. Unlike example law 6 here, where the numerator is not just have to do is a root of the x all raised to power b, or a root of s raised to power b, e.g. Let's take an example to apply that. We have 9 raised to power 3 over 2. If you have this case, 9 raised to power 3 over 2, from here, this means square root. If you put 2 here, we don't need to write 2 here because actually this is the symbol for square root. That's why 2 will not be needed here. Here we have 9 all raised to power 3. Then if you agree with me, this is going to give us 3 raised to power 3. And if you also agree with me, if you want to follow this or here, this means that we are going to have 9 raised to power 3, square root of 9 raised to power 3. Then we solve that, then 9 raised to power 3 is going to give us 729. Then we have square root of 729. Square root of 729 is going to give us 27. And here 3 raised to power 3 is also what? 27. We see either we do it in this way here, or following this other part, you still see that you are still going to arrive at the same answer. You are not to do the two together. All you just need to do is either go with this one or go with this one. But for clarity and understanding, that's what I'm trying to show us, that with the two approach, we would eventually get our answer. Let me also do another example. 4 raised to power 3 over 2. Following the first one, where we have this is going to be square root of 4 all raised to power 3. And square root of 4, that's going to give us 2 raised to power 3. Or if you are going to go with the second one, this is going to be the eighth one. When eighth root, we have s raised to power 0 is equals to 1. There's a condition to this, provided that x is not equals to 0. E.g., that means when we have 7 raised to power 0, that gives us 1. 10 raised to power 0 give us 1 here, but 0 raised to power 0 is not equals to 0 because it is provided that x is not equals to what? 0. So 0 raised to power 0 will not be equals to 0. So these are the basic rule of indices that I have discussed here. And one of the key to understand this rule and be better in them is to practice, solve more questions, practice more questions, because practicing more questions is what is going to make you understand this topic or be able to solve more problems. Thank you for watching this video. If you also stay more examples on indices, solved problem will also be out soon. So stay with the channel so that you can always get update on maths problems and other subjects. Don't forget to subscribe, like, and if you have found this helpful, share with your friends and classmates.